Are you curious about unit testing in Python? If you are, I've got you covered. By the end of this video, you'll have created your first unit test and use mocks to test your code. Software engineers tackle all kinds of problems in creative ways, often using AI to find the right solution. Hi, I'm Chuck. I've spent many years as a software engineer, and now I'm here to share my insights with you. Let's get into it. Open up your favorite IDE. Mine is a PyCharm, but there are many other great Python editors out there. Let's create a new file called test_basic. So the first thing we need to do is create a test class. So in Python, use class called test_basic. It's already adding some stuff for us there. And then let's create a function called test_basic. Self, and then we will add some code here. So this is the basics of a test. You'll notice we have some red squigglies and some yellow squigglies. We need to import a function and add a class to the class definition. So first we'll import the add function. So that's there. And then here, this is saying that we didn't inherit from the unit test.testCase class. So now you'll notice that the squigglies are gone. So now if we run this test, success, congratulations, you just created your first unit test. Before we move on, let's talk about how to structure a test. In software testing, there is an alliteration to remind engineers the parts of test. The alliteration is arrange, act, and assert. Let's structure our tests to follow this format. So first thing is we want to arrange. It's a common thing in tests where you'll see the test either commented, arrange, act, and assert, or it'll just be arranged that way. So we have the next one's act. The next one is assert. So our arrange is a left variable of value of 1 and a right variable of value 2, and we will put an expected sum of 3. And so let's take these values and replace our hard-coded numbers in the code. So we'll put left there, place that 2, and then we'll put the expected sum there. And then for act is just where the execution happens. Most of the time it's just one function, but some tests have more than one function. So put that up in that section. And then lastly, the assert. You'll find most methods have a single assert, some of them have more, but the asserts will go in this section here. And so if we run this again, it passes, we're good to go. So before we move on, let's talk about naming. So from a class perspective, in a test at least, I always prepend test before whatever it's going to be. So in this case, it's basic. So it's test basic. And then for the methods, oops, looks like I misspelled basic. Let's correct that. It's a convention that all the test methods have test_something. So let me remove this. Well, before I remove it, you'll see there's a green play button here in PyCharm. PyCharm is looking for this test_. But if we remove that, now PyCharm doesn't know that this is a test to run. So I'll put that back. And so once again, it's there. So, okay, that's the basics of a test. Let's move on to the next section. So what is mocking? No, it's not me making fun of you. Mocking in software development is using a fake object in the place of a real object. If you haven't seen my video on dependency injection, check it out. I talk about depending on an abstraction versus a concrete implementation, which lends itself well to using a mock. Python has a class called mock just for the purposes of mocking. The mock object keeps track of things like how many times a value has been accessed, or how many times a function was called, which is good when you're doing testing. Let's take a look at an example, and we'll create a new file. We'll call it test_mock. Just like before, I'll create a class. We'll call it test. Call test mock. We'll create another method called, well, a little too much going on there. We'll get rid of the body there. We'll create our own body. So we created a method called test_mock, but we need to add some. So this is very similar to what we had before. There's a small exception, is that first we're using a mock object, and we're creating a parameter or a variable called numbers, and that variable is being passed into add numbers function. Let's take a look at that add numbers function and see what's in there. Okay. So as you can see, the add numbers function takes an object called numbers, or it's a class called numbers. If we go to line 1 here, you'll see the class definition called numbers. Its constructor takes a left int and a right int and sets it to some values inside that class. Then this add numbers method or function takes that class and then adds those numbers together. What this does, this allows us to mock the numbers class. And so we've created, instead of creating the numbers, so for example, we could do this also and pass the same values in there. Now we have two variables that name the same. We'll comment one out. And so we'll run this and we get a passing test. Now let's comment that line out and we'll use the mock instead of the numbers class. And we will run that, and that again passes. And the reason is because it implements the left and the right values that the numbers have. So that is mocking. Mocking is taking an object and replacing it with your own object that you can control. Let's move on to the next topic, which is using async in tests, or specifically using async mock. Before we get into async mocks, let's talk about asynchronous code versus synchronous code. Synchronous code is code that is executed as it's written. Asynchronous code is also executed as it's written in most cases, but it's not guaranteed to run in the same thread. There's a common misconception that asynchronous code is the same as parallelism or threading. It's not. It can use different threads, but the work is still done in a serial manner, where in threading or parallelism, the work is done in parallel or at the same time. Here's an example. Your code makes a request to an external API. If the API request is a synchronous request, everything is blocked until that external API responds. That means if your application is single-threaded, everything comes to a halt. If it's an asynchronous request, the request is made to the external API, and then the CPU goes off and does other work while it waits for the request to come back, and it'll periodically check to see if the request has returned. So that's the difference between synchronous and asynchronous code. Synchronous code stops and waits for the work to return, and then asynchronous code will start the work and then goes off and does other things and then comes back when the work has been completed. Most of the time, you'll find asynchronous code more performant than synchronous code. Now that we know the difference between asynchronous code and synchronous code, let's take a look at asynchronous tests using async mocks. Let's create another file. We'll call this file test async. Like before, we'll create a class. We'll call it test async. We'll inherit from the unit test class. We'll create a definition called test async, or a function called test async. and we'll start putting some code in here. So we'll create a variable called greeter, and it's going to come from a class called greeter. Let's look at the greeter class before we move on. So the greeter class is just a simple class for this testing purposes. It has a get greeting prefix, which creates a async IO sleep to simulate async operation, and then it returns hello. You'll notice that the keyword async is in front of the asynchronous method, and then on the method definition, you have the keyword async, and this tells the runtime, the Python runtime, that this is an asynchronous method and they treat it as such. And then on line 11, we have another method called greet that calls the above method. Even though there isn't any async code in here, well, I guess you're calling the async method, so it is async code, but the async work is being done on line 7. You still have to await. Any async method has to be awaited. So you have await here, which means if you have await there, then you also need to prepend async in front of the method definition here. So we have 2 async methods in the greeter class. So let's go back to the test. And so let's import this. So another thing before I forget, we can't use test case class to inherit from because it does not support async mocks. So let's add the one that does. It's called isolated async IO test case. So we're good to go there. So let's create a variable, and it almost got it right. So we're creating a variable called mock get greeting underscore prefix. We're going to do async mock, and we want to return the value high. Okay. And it needs to be underscore value, not just return. Okay. Now we're going to take that function we just, or that method we just mocked, and we're going to do greeter dot get greeting prefix, and we're going to set this mock to it. So there we are. We're going to create a name to greet. We'll say John, and then we will capture the result in a variable called result. We'll do await here, and we'll do greeter.greet. And as I mentioned before, we use an await, but we also have to put async in front of the def keyword there. You can see the error went away. And then lastly, what we'll do here is we'll do self dot assert or equal. And so we're going to return the value of high to the caller of this function because we're mocking the function. The name to greet is John, and then we're going to pass the name in there. And if all works out as expected, then this result will match this string. So let's run it and find out. Sure enough, it matched. So now if we were to change this to say howdy, then this assert should fail. Yes, it's saying hi John is not equal to howdy John. So this is what we expected down here. And if we go back to the greeter class, we can see that on line 8, we are hard coding hello in here. So, and hello is not showing up, so the async mock is working as expected. So let's change this back to hi. Run it again, and it should have fixed the test. Yep, it's fixed. So that's async mocks. It's very similar to just the regular mocks that we use on the synchronous code. It's just yet another tool that we can use to test our async code. So the next topic I want to talk about is a patch. What is a patch? A patch is a decorator that, when applied to a test method, can intercept almost anything in the call stack. Let's revisit our async mock example, and I'll show you how it works. On the method, we will do that patch, and it'll be, I think that's right. Import patch. We didn't tell patch to use the async mock class, so we will do new underscore callable async match, async mock, excuse me. And then down in the method here, we pass in mock greeting prefix, and this eliminates the need to actually define the mock in the test. So now we take this passed in parameter, and well, it did it for us, and we do return. No, that's not what we want to do. We want to set the return value to high. And so now we're setting this parameter coming in to return value of high, and then we're setting that parameter, that async mock, to the get underscore greeting underscore prefix method. So this should work as before. Let's run it and find out. Yep, it passed. So what patch does is it intercepts the greeter class and replaces the get underscore greeter prefix with the async mock, and then passes that object that it replaced it with into the test method or the test function. And that's patch. So patch allows you to intercept anything in the call stack for the most part. You can stack patches. So let's say we had this here. Whoops. We could add multiple levels of patch like such. One little thing that's a little tricky is the count for the parameters into the method start from the bottom. So you would have the first one here is the first one right here, and then you would have the second one would be something like this, but we would just make it 1, 2, and so the second one here would correspond to this line number 10, and then this third one here would correspond to line number 9. And that's how a patch works. Now that we've built up a small set of unit tests in Python, we need to run them. The best way to run all the unit tests is via the command line. This enables you to run your tests on a build server or locally. So let's open the command line up. And let's do Python. We'll do -m unit. Spell it test. Discover. Do -s and provide the folder. And then we'll do -v for verbose. And so when we hit this command, it should go through the test folder and run all of the tests. And it did. So it ran the 3 tests we created. So great. That's what we expected. I hope you learned something today. And if you like this video, click the like button. It helps others find my videos, and it helps me grow my channel. And if you're new here, consider subscribing. To connect with me, you can comment below, or I'm also on social media or via my website. The details are in the description below. Thank you for watching.